Hey guys, sorry about that interruption. So let's pick up right where we left off. So we see our zeros are x equals -1, x equals -1, x equals 6, x equals 6. As well as, don't forget about this, x equals 0. So I'm just going to put markers at -1, 0, and 6. I know something's happening there. Now I'm going to look at my degree. I see degree 5. Don't forget about this x here has a degree 1. So my end behavior is going to be opposite. My leading coefficient is positive, so it's going to end going up, which means it'll start in the downward direction. Now at x equals -1, I have a repeated 0 here. So I know I'm going to have a turning point at -1, and at 0, it's going to go straight through. So it'll look something like that. And then at 6, I have another repeated 0. Okay, and then I'm just going to go ahead and connect the dots. Again, rough sketch, but look something along those lines. All right, number 5, find the sum or difference. So if I'm looking at number 5, my first step is going to be to distribute that negative, and then I'll rewrite this, 3x squared minus 2x plus 10 minus x squared plus 3. Now I just simply combining like terms. I have my x squareds, my constants. So I get 3x squared minus x squared gives me 2x squared minus 2x plus 7 is my final answer. Now finding the product, so we're multiplying. Don't forget we need to get that all these terms here. So I'm first going to multiply by x to the 5th. So I get 4x to the 8th. Remember, when I'm multiplying, I add those exponents. Minus x to the 7th plus x to the 5th. Now I move to the negative 3x squared to get me negative 12x to the 5th plus 3x to the 4th minus 3x squared. Okay, now again, I'm going to look for like terms, which in this case is just the x to the 5th term. So my final answer is 4x to the 8th minus x to the 7th minus 11x to the 5th plus 3x to the 4th minus 3x squared. All right, number 7. Now finding the product here, I see we have this binomial to the 4th, so I'm going to use the Pascal's triangle. Remember, this is Pascal's triangle. All right, I'm going to stop there. Now, I'm to the 4th power, so I'm using this row right here. And those are the coefficients I'm going to be looking at. So I'm going to write out my coefficients. 1, 4, 6, 4. I'm going to actually move this up here. Oh, maybe not. And then the plus 1. Now my a term is 3x. So remember, I start 3x to the 4th, right? Coming from right here. And then it goes down by 1 each time. 3x to the 3rd, 3x squared, 3x to the 1st, and 3x to the 0. Then I'm going to go ahead, look at my -2. I get -2 to the 0, -2 to the 1. That would be to the 2. -2 cubed, and -2 to the 4th. Now I'm just going to simplify. So I got 3x to the 4th, which is 81x to the 4th, and then -2 to the 0 is just 1. Plus I got 3x to the 3rd is 27x cubed, And then I need to multiply by 4. So I take 27 times 4 to get 108. And then times, let's see, 108 x cubed times negative 2 to the first plus. Now I have 3x squared is 9x squared times 6 gets me 54 x squared times negative 2 to the second is 4. Plus here I just get 12x, and then negative 2 to the third is negative 8. Plus 3x to the 0 is 1 times 1, and then negative 2 to the fourth is 16. All right, now again, I'm just gonna simplify yet. This is nothing to do there. Plus, I take 108 times negative 2 to get, this will be negative 216 x cubed. Plus 54 times 4 is 216 x squared. This will be minus 96 x plus 16. All right, I'm going to use the same concept for this number 8 as well, except for now I'm looking at these coefficients. They are, I'm going to write them down below so we don't get them mixed up. I'll use green for this problem. 1, 5, 10, 10, 5, and 1. Now, notice my A term is 4x, so I'm going to do the same thing, 4x to the 5th, 4x to the 4th, and then remember this is going down by 1 each time. Now I'm looking at the plus 3, so I get 3 to the 0, and this is going up by 1 each time. All right, now I'm going to simplify all these. So I get 4x to the 5th is 1024. Plus 5 times, well, 4 to the 4th is 256 times 5 gives me 1280. And then I'm just going to go ahead and multiply by 3 right away. So 1280 times 3 gives me 3,840 x to the 4th. And then same thing, I'm going to take 4 to the 3rd times 10, and then I'm going to multiply by 9 to get 5,760 x cubed. Wow, that got messy. Plus 4 squared is 16 times 10 is 160 times 27 gets me 4,320 x squared. Plus 5 times 4 is 20 times 3 to the 4th is 81, which gets me 1,620x. Plus 3 to the 5th, which is 243. All right, and that is number 8. All right, use long division to solve. So I'm going to set this up. We got x cubed minus 4x squared. And then don't forget we need to put those placeholders in for the x and that constant term. I'm dividing by x minus 3. So I'm looking at how do I get to x cubed? I need to multiply by an x squared. And I get x cubed minus 3x squared. I need to subtract that, so my x cubes cancel, and I'm left with negative x squared. Now I'm going to bring down my 0x. How do I get to negative x squared? I need to multiply by negative x. So I get negative x squared plus 3x. I subtract, my x squareds cancel, and I'm left with negative 3x. Again, bring down your 0. How do I get to negative 3x? Well, I need a negative 3. Subtract, and I have a remainder of negative 9. So that I'm going to add to the top and put over my divisor, remember. My final answer is right there. All right, this one, it looks like we have all the terms, so we don't need, for number 10, we don't need any placeholders, so we can go ahead and write this out. All right, now how do I get to 4x cubed when I have 4x already? Well, I need to multiply by x squared. Gets me 4x cubed plus x squared. Subtract, my 4x cubes cancel, and I'm left with 12x squared. Bring down my 27x. How do I get to 12x squared? I need to multiply by 3x to get 12x squared plus 3x. Subtract, 12x squared cancel. I'm left with 24x. Bring down my 6. How do I get to 24x from 4? I need to multiply by 6. It gives me 24x plus 6. So when I subtract, everything cancels. I get a remainder of 0. So my answer is x squared plus 3x plus 6. Number 11 and 12, we're using synthetic division. So again, when we're using synthetic division, we're only looking at our coefficients. So 4, now notice we're missing our x squared term, so we need to put a placeholder in there. We're also missing an x term, so we need to put a placeholder in for that. And then we have negative 16. Now don't forget this, we solve for x to get x equals negative 3 is what goes on the outside there. My 4 goes down, and then I multiply. 4 times negative 3 gets me negative 12. Add to get negative 12. Negative 12 times negative 3 is 36. I add. 36 times negative 3 is negative 108. Add those to get negative 124. Now remember this last number here is my remainder. All right, so my final answer, and my answer, remember, is 1 less degree than what I started with. So I started with x to the third. So my answer is going to be x squared minus 12x plus 36. And then my remainder is negative 124 over x plus 3. All right, same idea here for number 12. We have coefficients of 2, negative 11, 11, 4, 4. I'm dividing by x equals 4. My 2 goes down. 2 times 4 is 8. I want to add those to get negative 3. Negative 3 times 4 is negative 12. I get 1. Negative 1, excuse me. Negative 1 times 4. Negative 4, I get 0. 0 times 4 is 0. I add to get 4. My final answer here is, remember, 1 less degree. I started with x to the 4, so here I'm going to start with x cubed minus 3x squared minus 1x plus 0. So I'm going to skip that and do plus 4 over x minus 4. Remember, this is my remainder. All right, now we're moving on to solving, finding zeros. Remember that if we're looking for zeros, solutions, roots, x-intercepts, those all mean the same thing. We set it equal to solve and solve for x. So that's exactly what I'm going to do here. Set this equal to 0. Now, the first thing I would do is look, is there anything in common in each and every one of those? There's not. And I can't factor by grouping. This isn't a difference of 2 cubes. So I need to resort to the rational root theorem, which tells us what the possible zeros are. So I'm looking at the 4 and the coefficient here. So my possible roots or zeros, remember, are the factors of 4 over the factors of, in this case, 1. So I'm looking at plus or minus 1, plus or minus 2, and plus or minus 4. Okay, and how I got those factors of 4 are 1 and 4 and 2 and 2. So I'm looking at, I'm going to write that like this. And those are over, my only option here is 1. So that's each of those over 1. And then don't forget it's plus or minus. Okay, so that's where that came from. Now I'm going to use synthetic division to find those zeros. Okay, so my coefficients are 1, -4, 5, -4, 4. And I'm going to start with 1. That's just my gut. That's what I always do. Bring down my 1. 1 times 1 is 1. That gives me -3, -3, 2, -2. And I have a remainder. So positive 1 is not a 0. Now I'm going to move on to -1. And this is also not a 0, so I can cross 1 off my list. Now I'm going to move on to 2. 1 times 2 is 2. It gives me -2 times -4 gives me 1. Perfect, I get a remainder of 0, so I know that x minus 2 is 0, so I'm going to go ahead and write that up there. X equals 2. Okay, now I'm left with, I'm going to rewrite this as x, remember I started with x to the 4th, so now I'm x to the 3rd minus 2x squared plus x minus 2. All right, now I notice this is 4 terms, so I'm going to first start by and try factor by grouping. In this first one, I can take out an x squared, and I'm left with x minus 2. In the second one, the only thing in common is a 1, and I get an x minus 2 if I take out a 1. These two match, and that's exactly what I need. So I have x squared plus 1 and x minus 2. Now this is set equal to 0, so I need to set both terms equal to 0. And I get x equals 2. So I see that that repeats twice. Perfect. And then I have x squared equals -1. Take the square root, and remember the square root of -1 is I. So I have plus or minus I. All right, so now if I look, we started with a 4th degree polynomial, and I have 4 zeros, so that's always a good check. All right, we look at this number 14. I see 4 terms, so my first gut would be to try factor by grouping. I'd take out an x squared, and I'd be left with x plus 12. And then I notice there's nothing in common between 41 and 72, nothing I could take out. So factor by grouping doesn't work. So again, we're going to have to resort to the rational root theorem. So I make a list of my possible zeros. which is all the factors of 72 over 1, which gives me a very lengthy list, unfortunately. I get plus or minus 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. All right. Now, I would start with 1, go to -1, 2, -2, 3, -3. I'm not going to go through all those in the video. The first root is -8, and I just know that by doing this problem already. But for you to arrive at that solution, you would have to try either guess randomly and get lucky, or try positive and negative 1, 2, 3, 4, 5, 6 before you get -8 to work. I'm not going to take the time to do that in this video, but I'm going to start with -8 because I know that works here. Okay, so one of my factors, I'm going to write this in red, x equals -8. Okay, and then from there, once I do that synthetic division, I have x squared minus 4x plus 9. Okay, from there, I would try to factor. We know how to factor quadratics. And then I run into this problem. No way with 3 and 3 to get -4. So this actually doesn't factor, and we need to resort to the quadratic formula. All right, which is -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so this is x equals 4 plus or minus the square root of 16 minus 36 over 2, which gives me 4 plus or minus the square root of 20 over 2, which is 4 plus or minus 20 breaks up into 4 times 5, and 4 is that perfect square, so that's going to come out. And then I can reduce this even further to 2 plus or minus the square root of 5, because we can divide all of those by 2. Right, and that gives me 3 answers. Perfect, -8 and 2 plus or minus the square root of 5. All right, I'm gonna stop here and create a third video.